Now, the intensity of a sound wave, as it turns out, depends on both the frequency of the sound wave and the amplitude of the sound wave, which makes things a bit complicated. So, right now we're not going to be worrying about the frequency too much. Keep the frequency fixed, so the frequency is constant, which means that the intensity of the wave will depend on the square of the amplitude. So that means that if we increase the amplitude of a wave by a certain factor, its energy will increase by the square of that factor. And as I said, this is as long as we're keeping the frequency of these two different waves constant. If we're looking at data from graphs, then this can be very helpful. You can see over here that I've got two graphs of waves, except one has twice the amplitude of the other. So how will that change its intensity? Well, a sound that has twice the amplitude, like over here, will have 4 times the intensity. And this means that it will be 4 times as loud. A certain 800 Hz sound is 8 times louder than another 800 Hz sound. Now, because the frequencies are the same, we don't need to worry about how they affect the volume. So if the sound is 8 times louder than the other sound, by what factor is its amplitude greater? Now, how does amplitude affect intensity? Well, we learned right back at the beginning that if we double the amplitude of a sound, then we quadruple the intensity. That is, the intensity is proportional to the square of the amplitude. If we square the change in amplitude here, we'll end up with 8. Well, 8's not a square number. So, what's our answer? Well, if it's 8 times louder, then its amplitude is the square root of 8 times greater. We can of course simplify this using a calculator to 2.83. So, the amplitude of the sound is 2.83 times greater. If you square that using a calculator, you'll get a number that will tell you that it's very close to being 8 times more intense.